Hi everyone. So I'm a week into my studies now, back at university in my second year, and so far so bad. As in, yeah, bad. It's not going well at all. Basically, I'm just not understanding anything, and the structure of the way that they've done it as well is a bit of a joke. So yeah, it's not fun, but it is what it is. You just gotta make the best of it, right? So I've got two modules that I'm doing right now. My electronic and electrical principles two, and then my instrumentation and control module. So what I'm currently doing now is I'm trying to just get a decent idea. So I've had two lectures. I'm trying to get a decent idea of what it is that I need to learn about, just in particular, and then how I could try and learn as much as possible about those particular topics, just so that at least I can pass the module. And then I need to dedicate, probably a few hours a week to going back and actually learning the basics. I need to learn a lot of the maths behind what I'm learning, and I also need to learn just a lot of the basic electronic stuff. Basically, this year there's been this like massive assumption that somehow, you know, us second years have learned way more than they taught us in our first year, which is just crazy. So, and I'm not even talking about just teaching us, even what they examined us on. Yeah, I mean it's crazy anyway. So I've got my two lectures here. I'm swinging through them, and I'm just making notes on what topics they want. They what topic the lecturer has discussed in the lecture. Then I'll then go and make some questions on it and teach myself those topics. So yeah, basically you pay here in the UK anyways. You pay nine and a bit grand, £9,250 a year to teach yourself from a book. But I'm sure it's the same for most of you guys wherever you are in the world. So let's just get onto it and let's just learn from books and YouTube, eh? Alright, so topics discussed. So I'm at magnitude values. Let's get there. My lecture. I mean, I don't even understand what this stuff is really actually. Periodic, so sinusoids, periodic waveforms are written as okay. So probably need this information here. So sinusoids. At the moment, I'm literally just gathering information. I'm not looking to learn it right now. I'm looking to gather to find out what I need to learn. And that's kind of like how I see my lectures anyways. I see my lectures as just a way for me to learn what it is they want me to learn. For me personally, I don't learn anything from a lecture. Alright, so the average value. We've got magnitude values. Average value of a positive or negative half cycle as denoted by voltage average. Okay, so the average value of a symmetrical waveform is the average value of one half cycle. By definition, V average is equal to area under the curve divided by the baseline. Alright, don't know what that means, but it's all good. So you're going to see me in the next few videos basically breaking this down into what these words actually mean. So average value. The V average is equal to 1 over pi, and then just a whole bunch of equations which I have no idea what they mean. Alright. Just screenshot this because maybe after a few videos it will start to make sense. Equations. Okay, don't know what that means, but that's alright. Alright, so now we're on to the RMS values. RMS value. Let's write out the full thing. What was it called? The root mean square. Root mean value of a squared function. So RMS value. Go. Alright, so the RMS value of an AC current or voltage is very widely used in practice. It relates waveforms of power or energy basis. Unless otherwise stated, as currents and voltages are understood to be given in RMS values. Okay, it is a square root of the mean value of a squared function. Cool. Alright. Consider the current flowing through a resistor of value R. I is the amplitude of the current, and then you've got time okay. So let's write this. Let's put power example, power light bulb example. This is definitely not how you learn the topic. So don't for one second think that you can learn anything like this. This is more like scoping the subject and getting to terms with what they're trying to tell you. So then we've got average power dissipation calculation with average power dissipation calculation. So basically what we're saying is that obviously E equals V times I, or power is equal to I squared times resistance. So you're just saying that the P equals VI for here, or the P is equal to I squared times R for here. Take all of those points, divide it by, what's this, the number of points you're taking? Yeah. The average power dissipation calculation. Imagine your DC current of value I produces the same heating effect in that resistance. Therefore, V is equal to I squared. Breaking these two equations. What? Where'd you get that from? Oh, okay. P is obviously equal to I squared times R. Okay, so this is talking about how you get to the square root of the mean value of a squared function. Okay. Okay, so kind of hard to put this into here. So deriving RMS calculation. You got the average power dissipation calculation, yep, and then you've got since P is equal to I to the power of 2 times R, right? Average power dissipation calculation, and then replacing P with, so you got the P here, you're replacing it this, and so you've got I squared times R is equal to I squared. So what they're doing here is, what have you done? You've divided both sides by R. How did you get the I to the power of 2? You know, that's fine. Wait, what? You've divided both sides by R here, and then you've taken the square root. Okay, got it. Then dividing both sides by R, then taking square root. Got it. Okay, I'm all right with that, I suppose. Okay, and then now how you getting this? Like, where did this come from? Okay, I'm okay with this. How you get into this? I don't even know what half of these signs mean. Um, Therefore, VR. What? We calculating something? Why? VM. What's VM? Cool. VRMS calculation. Alright, don't know what that's for. So, importance of RMS value. Consider a sinusoidal waveform has the following components. No, I don't understand that. Importance of RMS value. Chopped. Following components. Okay, I don't get that. Sine wave, square wave, triangular, dinosaur. Thank you. Any questions? Yep, loads. Alright, so lecture 2 now, phases. Let's move on to that. So, if I can just basically understand from lecture 1, waveforms, sinusoids, some of these random Greek letters that I'm seeing. Although, you know, let me actually get a list of some of these random Greek letters that I'm seeing. At least record the ones that are coming up in these lectures. I'm just looking for the Greek letters. All right, so basically this, don't know what this is all about. Maybe I don't know. I think this is probably relevant. Okay, any more? There's this one. Oh, this weird one is what my lecturer told me what it was today actually. Weird O with line through it. Like a backward Q, isn't it? Greek letter backward Q. Copper? Copper? Was it copper? That doesn't quite look right. I mean, that isn't. That's probably it, isn't it? Who knows, man? Who knows the Arabic letter Qaf? I know that one at least. Don't know why we need these bloody letters. Let's put electrical engineering Greek letters. Okay, alpha, beta, gamma, delta, eta, theta, iota, kappa. Sigma. That was what? Oh, that was it. Phi. That's it. Phi. Then what's this? This is okay. I'm kind of alright with that. Um, Okay. Any other Greek letters? Obviously, there's pi, but I'm alright with that. There was this equation here. I don't know functions at all, really. I haven't done that. I assume it's like calculus stuff. I haven't done that at all. There's these D's and stuff like that, which I don't know what they're for. Okay, that's fine. We'll be okay with that. Let's move on from that. Let's go on to phases. So we go to lecture 2. So what I'm gonna do is in the next video, I'm gonna basically expand on all of these, and I'm gonna try, even though I think it's gonna be very difficult. I'm gonna try and get my head around what these topics mean. If I can just at least understand these, then hopefully I can understand my first lecture, and then hopefully I can have something to build off of the plan. So oh, oops, that's my lecture. Open that from here. Oh no, it's already open. Never mind. That's fine. All right, so we've got phases, phase, this kind of stuff. So let's go. Phase. We've got a phase. I don't want this video to be too long, so I'm gonna just write down the topics. I'll look on. We'll do it quickly. Phase. I'm always like, yeah, you know what? I'll do a 10-minute video quickly, and then it'll be in 40 minutes. Phase. Then we've got lagging and leading. So in phase, we need to cover what it means to lag and lead. Lagging, leading. That's an important point that the lecturer mentioned a lot today. Things being in phase, anti-phase. So you got in phase, anti-phase. I heard all of these phrases for the first time today. So phase, quadrature, don't know. Then you got the phasor diagram, which I kind of understood today-ish. If it's like double the length, then it's double the magnitude or something. Phases rotate counterclockwise. Okay. So you got phasor diagrams. Yep. So now we need to get just kind of touched on complex numbers, but I want to do some actual problems on it and just get comfortable with j is equal to -1 and stuff like that. I really should have done a lot more maths over my summer holidays. Alright, so quadratic equation, I'm okay with that. And then he's basically going into why we need to use the quadratic equation, which is fine. Basically, if you want to find the square root of -144, then you do the square root of +144 times by the square root of -1. Square root of -1 is obviously j, and then square root of 144 is 12. So you got plus or minus 12. So you got plus or minus 12 times square root of -1, and that gives you plus or minus 12j. I'm comfortable with that. I get that. I'm alright with that. Then now you got polar form. No idea what that is. Polar form. Every time I hear it mentioned polar, I think of a polar bear. So he was talking about using Pythagoras' theorem to solve this. Yeah, that went way over my head. Did I get that last bit in there? I didn't. What was this? So where r is the magnitude of z. Well, okay, so where's z here? Okay, z is this line here. All right. You got magnitude of, what's this supposed to be? Is this that Q thing? Engineering Greek letters. That weird Q thing again, isn't it? Not sigma, not phi. It's not these. Circle with an O in it, but which one? They look similar. I can't see it. No, am I? If you know which one it is, let me know in the comments. But I'm gonna guess it's phi again. Angle of phi. We don't know. All right, is what it is. So now you got a rectangular form, polar form, and exponential form. Okay, so you got polar form, rectangular form, which I'm guessing rectangular form is just standard. Z is equal to x plus jy, and you got exponential form, So I think we're going to need to learn how to convert between the two of these. All right. Complex numbers operations. So this has to do with complex numbers. So we're going to need to learn how to. I don't even know what is this even. It's a joke that this is just being taught to second years without actually telling them, hey, by the way, you're gonna have to learn this. How long is it gonna take me to understand this foreign language of all these symbols? Alright, applications. He wants me to evaluate something. Again, applications, waveforms, phasor diagram. Okay, polar, rectangular, and that's it. Alright, so that's my 2 lectures on electrical and electronics, or electronic and electrical principles 2. So at least I now know what I need to actually study and go over. And so my next lecture, I've got a tutorial with this lecturer on this module tomorrow. But that's going to be mostly multi-sim based. So I don't know if I'm going to use any of these. The terms will be used loads, and I probably won't understand any of them. But I don't think I need to know any of these by tomorrow. But the plan is by next week, I can be fully concrete grounded with these, do a bunch of example questions and stuff like that on these, just get really comfortable with it. So that's the plan. Yeah, let me know if you have any input, anything that you think that can help me learn this stuff. I'm probably like you going to be learning it off of a combination of PDF books, YouTube, and then those like electronics websites. So use a combination of those, and hopefully if I get time I'll make some videos of me learning these as well. So yeah, thanks guys for watching, and I've got my next lecture now in 10 minutes time, which is on control as part of my instrumentation and control module, so that should be fun ish. See you guys in the next one. Peace.